Chapter 17 is about proofs. How do we prove that something is true? First of all, we must understand the idea. Simon says sum of the interior angles in a triangle is 180, quadrilateral 360. Therefore, any polygon, you know what's a polygon, right? N-sided polygon, with 5-sided is a pentagon, 6-sided is a hexagon, etc., etc., is given by this formula. Is Simon correct? All of us will say Simon is correct. How do we prove that Simon is right? Okay, never mind. I give you another example. I say this statement. All agree? How do you prove that this statement is true? How do you prove that this statement is true? You must find all the JC boys. Of course, we must have some criteria, okay? Some criteria. We must find all the boys line up and then prove that each one of them is good. Alright? Every one of them, every one of them. How do we prove that? Just find one boy. Just find one boy. So very nice the beauty of mathematics. See, to prove that something is true, we need to find all the boys. Okay, I give you another statement. Maybe, this one confirm not true, right? Okay, wait. Maybe you should get this. Or maybe we should. Okay, enough. My point is, again, if you want to prove that to be true, hello? Okay? My point is, if you want to prove that to be true, you must find everybody. You must find everybody and line them up. You want to disprove that, you just find one teacher. Don't look at me, Then you can disprove. So back to the example on the triangle. We can't just accept this as the truth until we prove every possible polygon. But how do we find every single polygon? Because you can have polygon with 10 sides, 11 sides, 12 sides, 13 sides, 1,000 sides. Can we find all the cases? Not so easy. Therein lies the beauty of the domino concept. In mathematics, this is called induction. Never mind if you don't quite understand. Let's look at the domino again. Okay. If you line the dominoes up, okay, 1 domino, 2 domino, 3 is 1, and many dominoes. How do we ensure that all the dominoes fall? First, if my first domino were to fall, that is a good start. But if my first domino is here and my second domino is here, this thing falls, second domino don't fall, that's not a good start, it's never enough. How do we ensure that all of them fall? I ensure that first one falls. The second condition lies here. Look at this line. For any k, that means in between, for any k, if I can prove that if the k domino fall will cause the k plus 1 domino to fall, then all my dominoes will fall. Why? Because my first one falls, right? And because of the highlighted condition, the second one will fall. Because of the same highlighted condition, my third one will fall. And fourth one will fall. And so on. So I don't need to do all this. I only do first case, first domino, Before, I also need to ensure that the k domino will cause the k plus 1 domino. So if you recall how the domino was set up, it's like that. The space between each domino is such that the k domino will cause the k plus 1 domino. So if we go back to the triangle example, if I can prove that, okay, it is true for the triangle case, it's true for triangle case, if I can prove that if the formula n minus 2 plus 1 is true for the k case, then the k plus 1 case is also true, then by mathematical induction, all is true. You follow what I'm saying? Okay? I think you get the drift for domino, but how it actually applies to mathematics, not so clear yet. Let me demonstrate. Okay? Let me demonstrate. Okay. Sorry. Hey, why like that? Ah. Oh, that's me. Okay. So, 17.2 says this. Okay? All you need to prove is to prove that the first case is true, where A is the smallest possible value of n. Then after that, if pk true, imply pk plus 1 true. Analogously, you look at the domino. Can? Have we look at the domino? It's analogous. Correct? If pk is true, that means in the middle somewhere in the k domino is true, it falls, we have to assume that the k domino falls. So the assumption is with pk being true, it causes the k plus 1 domino to fall. It will cause the pk plus 1. Never mind. Let's do example 2. Never mind. Let's do it together. Now the question asks us, okay? Is there a typo? Yes, there is. Of course. How can it be minus 1? Okay? Okay? 3 sides. 3 sides must be 180, right? What is this, man? Okay. Can I have attention? Attention. First, we prove, can I have attention? We prove that this thing is true. This is a statement that we must say. What do we want to prove? You want to prove that this thing is true. This is what we call the statement. What you want to prove. What do you want to prove? You want to prove this statement. First step is this. Consider P3. That means for n, the smallest value of n. You consider the smallest value, because you want to consider the first domino. No point the domino starting from 2. No point starting from the second domino. You must start off from the very first domino. But in this case, the smallest n must be 3. Because it can only be a triangle. With only 2 vertices, it's a straight line. It can't be a polygon. Correct? Triangle. So we say, okay, left hand side of P3, that means the sum of interior angles in a triangle, it is a well-known fact. It is 180. Well-known fact. We accept that to be true. If we use the formula, we sub n equals to 3 here, n equals to 3, the right hand side, then the formula works. We can only accept that the formula works for n equals to 3. And we have shown that. So far so good. We have shown that the formula works for a triangle. Not good enough, right? Not good enough, huh? So we have to prove that if it works for a k-sided polygon, it should work for a k plus 1-sided polygon. So now the next step is to assume pk is true for some k. Some k. Assume only, assume. Okay? Assume that is true. We use that assumption to prove that pk plus 1 is true. How do we do that? Okay. Now, let's look at this. Let's look at this. We want to prove that we want to show that the pk plus 1 is true. That means we want to prove this thing. Correct? We want to prove this thing. Yes? Okay? Well, how does a k plus 1-sided polygon look like? Very hard to draw, but let's say, okay, you have 1 point, 2 point, 3 point, 4 point, all the way to k points, and then k plus 1 points. Okay? And we want to show that the sum of the interior angle is given by this formula. Then we make a very smart thing. Wait. We do quite a clever thing, I feel. We cut this one like that. Why do we cut this one like that? Now, this shape, no matter how many points are there here, is now a k-sided polygon. Correct? The highlighted shape is now a k-sided polygon. I've taken away the k plus 1 vertex. Correct? Now remember our assumption? Our assumption is that pk is true. That means the sum of all the interior angles in a k-sided polygon is given by this formula. We accept that as true. We assume that to be true. If we assume that to be true, then the sum of the interior angles with k plus 1 vertices must be all these angles plus these 3 angles here. Correct? What is the sum of these 3 angles? Must be 180 degrees. So, therefore, we get 180 plus this one, which was from the assumption that pk is true. Right? This is from the assumption that pk is true. Keyword, assume. We're not saying it's true, but we assume it's true. Then we can show that, from here, I factorize the 180 out. Sorry. We factorize the 180 out. Then we get k plus minus 180. So actually, we have shown that pk plus 1 is the formula works for pk plus 1. Okay, let's put everything together. I know it's a bit tough going, but let us put everything together. Remember, we said we have shown that for a triangle, that formula works. That means for a 3-sided figure, the sum of the angles is 180. And then we assume pk is true. We assume pk is true. This will imply pk plus 1 true. If pk is true, the keyword is if. If pk is true, pk plus 1 is true. Now, using these two, we can say that since pk3 is true, then p4 is true. Using statement number 2. Because we've shown p3 is true. Correct? Then since p4 is true, p5 is true. Since p5 is true, p6 is true. Since p6 is true, p7 is true, and on and on and on. There you have proven the formula for all integers greater than 3. Can? Actually, my lecture for this chapter can end here. No, really. Actually, that is the concept of mathematical induction. No, I'm joking lah. You know what I'm saying? But the rest are examples, okay? So can we take about 2 minutes to talk to your friend about this idea of mathematical induction?